And welcome back for another version of Hamilton Teaches. Today's topic is going to be all about soil. As we move through, we will start with a very simple explanation of what soil is. First of all, you have to understand soil is not dirt. We need to take a close look at soil and understand it. And in fact, we're going to be studying it very up close and personal. So be ready for today's lecture. And hopefully by the time you're done, you'll have a good understanding of what soil is really all about. All right, let us start with the general makeup of soil. All right, now soil itself is made up of mostly mineral matter. We're a little bit less than half of mineral matter. And that mineral is actually from the rocks and from the erosion and from the actual inorganic materials that you find. That makes up less than half of what soil is. And what people don't realize is much of our soil is really just made up of air. About 25% of all soil is air. That air is super important to keep the soil, and especially the plants, healthy and the soil well aerated. 25% of, or another quarter of soil, is made up of water. And that you'll find in between the air and the water, you'll find in between the mineral particles, which you'll see here in a minute. Then the remaining 5% is made up of organic material. All right, and we call that the humus material, humus layer. All right, which we'll talk about in great detail. And that's broken down organic material, broken down plant material, decaying plant material. And then, of course, you have a few of the organisms left in there, which we will see here in a little bit. Okay? And for some reason, we don't want to move on here. Give me a second. Here we go. And soil, if you look at it very closely, you'll see that the 45% that is made up of the minerals, and those minerals can come in many different sizes. In this particular case, we have large mineral particles that we call sand. In between those particles, you'll have little spaces or air pockets, okay, which your roots will need. And they will actually work their way, as you can see with the roots here, they'll work their way down through the air particles, okay, and into all the water particles and stuff, which obviously is the last part, which is all filled up with water in between. That water is attached to the soil particles. If the soil particles are very big, that water will actually flow down and through. We call that process infiltration, and that's when the water goes down into your soil. All right, we give it a name called infiltration, and that is the water, once it goes down into the soil, it goes through the soil particles and continues down. All right, so that if you have larger soil particles, you'll find out that the infiltration rate will be greater, like sand on a beach. If your particles are much smaller, you have much less space between them, and your air pockets will be smaller, and the space for water will be less, and water will have a much harder time infiltrating your soil. And that has tremendous implications when we're looking at farming and how we use our soil. And once again, we're going to move down. Here's a look at the different particle sizes. When you put them all together, these different particle sizes, we call that soil texture. Whoops. And for some reason, we want to die here. Here we go. Soil texture. Texture is looking at the different particle sizes. And the texture of soil is really made up of 3 different textures. One is the clay, the second is the silt, and the third is the sand. And if you look at them relative to each other, you'll see that sand is by far the largest. Silt is the medium size and invisible at this scale. Clay at this scale is invisible. So clay particles are very, very small, and you can already know in your brief amount of time that you've been studying soil that if you have a clay particle, you would assume that the infiltration rate is slow because there's just not enough space for the water to work through. So you have these 3 particle sizes. Silt is the most I guess, desired soil size particle because it has just the right amount of infiltration and water going through, but yet it can still hold back water so you save it for plants. Sand, the water goes straight through and it's gone in an instant and there's no water left for plants. Real quickly, another name for silt, which you'll see on papers later, is called loam. So just keep that in mind. If you see a loamy soil, that means basically it is a soil that's made up of mostly silt. All right. And as we continue to move through, if you want to take another perspective, there they are. Those are the three different sizes. You can see sand, silt, and clay. Now, if you take those three sizes, and this is where it gets to be fun, if you figure out what percentage of your soil is sand, what percentage is silt, and what percentage is clay, you can then classify your soil texture using this triangular chart. So this is a soil texture chart, and we will use it a lot when we're trying to identify the different types of soil, and not just identify, but then come up with the soil characteristics. All right, so let's give a real easy example. Let's just say you did an experiment with your soil sample, and you found out that it was 30, here we go again, 30%, now we're having some fun here, 30% clay. Let's go, why not, 30% silt. That leaves us with 40% sand. So what you do is you take those percentages, go over to this chart, and you'll see your little arrows here tell you what direction to move on the chart. All right? So, and sand will go in that direction. So if you're looking at 30% clay, you go over to the clay side. It's down here at 30%, and you can follow the line across if you do it better than me. 30% silt. All right, silt is over on this side, right here, silt, and you go up to 30%. And then you follow that line down. If you notice, the two intersect right there at that one point. And then if you have 40% sand, sand is down here on the bottom. Those numbers go up on an angle in this direction, and you'll see that all three of those lines come to a point right here, which is in what we call a clay loam, and that's how you identify your soil. So what you're doing is you're figuring out the percentages of clay, silt, and sand, and then putting them onto this chart to find out what type of soil you have. So it should be very, very simple. So knowing that, let's give you one more example. Let's say you have 15% clay, 45% silt, and 40% sand. What type of soil do you have? Now with your fingers, kind of go through the screen, take a look. Clay at 15%. All right, silt at 45%, sand at 40%. And if you do that, I know I'm not giving you a whole lot of time here. Here's 15% on the clay. 45% silt, which puts us right here. Okay, and 40% sand, which puts us right there, and right there's your point in this soil called loam, which I just told you before is a silt soil. That is probably the most desired soil. So this percentage, okay, is a very much desired percentage because it does have some water holding capacity between the silt and clay. They'll hold water, but then at the same time you have some drainage in there. The water can infiltrate through because of the sand. So it just seems to be the perfect combination. All right, now that you are experts in all that, let's move on here.